Welcome to this video on Indian philosophy. This is the second video in the series of videos on Indian philosophy. In the previous video, I had led an overview of what to expect in the coming videos. Also, I had mentioned about the motivation behind creating this series. Please note that the aim of this series is to classify Indian philosophy based on dualism and non-dualism. In this video, I will be dealing with dualism. Firstly, we will classify dualism into two types. I will also discuss the reasoning behind such a classification. Next, I will define one of the types of dualism. For simplicity, I will be calling that definition as dualism 1. We will also be looking at the appropriate philosophy which suits that definition. Then I will try and build a mathematical equivalent of that definition. I know that such an equivalence would be vague, but we will still go ahead with it anyway for now, as it may help us draw parallels with physics later on. Lastly, we will discuss a phenomenon in physics which is in line with our definition of dualism 1. Okay, so now let's look at dualism. What is the aim of all the dualistic philosophies around the world? Dualistic philosophies are an attempt at explaining how reality comes about. Dual in dualism means two. More elaborately, dualism implies that the reality is a result of interaction between two elements. We won't specify what these two elements are, so for now let's just call them A and B. So, A and B are the dual in dualism. As I had mentioned earlier, let's classify dualism into two types. For simplicity, let's just call these two types as dualism 1 and dualism 2. Now let's talk about the reasoning behind such a classification. How is dualism 1 different from dualism 2? Of course, in dualism 1, we will have two elements A and B. The difference is that in dualism 1, reality is the result of two elements working together. The important word to notice here is the word together. What do I mean by this is, only when I consider A and B together will I have a reality. This implies that if I consider one element alone, then no reality will be associated with it. For example, out of the two elements A and B, if I consider A alone, no reality will be associated with A. Let's call such element as classical element. Meanwhile, in dualism 2, we will have multiple realities. Of course, even in dualism 2, we will have two elements A and B. The difference is that if I consider A separately, then A will have its own reality. If I consider B separately, B will have its own reality. And on top of that, if I consider A and B together, it will give rise to one more reality. So in dualism 2, we will be having multiple realities. I hope that the difference between dualism 1 and dualism 2 is clear. Let me summarize again. Dualism 1, we will have only one reality, which is the result of two elements A and B working together. Please note that A and B are classical elements, by which I mean that if I consider A separately, no reality will be associated with it. While dualism 2, we will have multiple realities. If I consider A separately, we will have one reality. If I consider B separately, we will have another reality. And if I consider A and B together, we will have one more reality. Okay, now let's look at dualism 1 in more depth. It states that a fundamental reality is a result of two and exactly two complementary classical elements working together. These two elements are coupled or entangled with each other. In the above statement, there are three things to notice. Firstly, reality is the result of two classical elements working together. I have already explained what are classical elements, and I have already explained that in dualism 1, two elements A and B need to work together to create a reality. Let me state again, classical elements are those which when considered individually will not be associated with any reality of its own. The second thing to notice is that the two elements have a complementary relationship with each other. I will in the next slide explain what this complementary relationship is. The third thing to notice is that the two elements are coupled and entangled. This is a very important detail. Coupled or entangled in the sense, if one of the elements undergoes a change, then the other element will react to that change. Let's continue our analogy previously stated, in which if A undergoes a change, then B will react to that change and vice versa. So such a relationship between A and B is said to be coupled or entangled. Okay, so now let's look at the question, what is a complementary relationship? Earlier we had mentioned that dualism is associated with two elements A and B. We have also said that the relationship between A and B will be complementary. Let's try and explain this complementary relationship between A and B mathematically. For this, I have considered a table in which the result of interaction between A and B is a fixed quantity. Let's assign a numerical value for this fixed quantity as 6. And I have given various numerical values to A and B. Please note that when A's value increases from 2 to 3, correspondingly B's value will decrease from 3 to 2. Such a relationship between A and B is called as a complementary relationship, and we can express this relationship nicely with a mathematical equation A into B equal to a constant. Now please remember that here A and B are classical elements which the equation itself does not reflect. So that's why I have given A and B a red shade. So this equation implies that if A increases, B must decrease, and if B increases, A must decrease. So this reflects the fact that A and B are complementary and that they are coupled. Also note that this equation A into B equal to a constant may look familiar for some. This equation is similar to the uncertainty principle of quantum mechanics, and there are many parallels with that equation as well, which I will be explaining in the coming videos. So for now, it suffices to say that this equation represents the complementary relationship between A and B quite nicely. Now let's look at the existing philosophies that are similar to our definition of dualism 1. Let's consider Taoism, which is an ancient Chinese philosophy which is about 2500 years old. Some of you may recognize this representation of Taoism as it is quite popular nowadays. So what I'll be doing is, I will analyze this representation of Taoism and then I will compare it with our definition of dualism 1. So let's jump right ahead in. In this representation of Taoism, there are two elements, white and black. And as you can see, the element white is locked in an eternal dance chasing element black, and element black is locked in an eternal dance chasing white. This is supposed to represent a state of entanglement between white and black. Also note that there is an element of black within white and there is an element of white within black. This is supposed to represent that white and black have a complementary relationship. So now let's start drawing parallels with our definition of dualism 1. Let's assign white with A and black with B. We know that our definition of dualism 1 is A multiplied by B is a constant. Now let's look at the statement of Taoistic philosophy. It states that all natural processes are characterized by this eternal dance of white and black, which leads to harmony. So we can translate that mathematically as white multiplied by black equal to harmony. So I know this is a very vague translation, but the parallel between Taoism and our definition of dualism 1 cannot be missed. Let us now look at a physical phenomenon which is in line with our definition of dualism 1. This physical phenomenon is called as quantum entanglement. At this point, I have to mention that this phenomena is not very well understood even today. It is said that two Nobel laureates, Albert Einstein and Niels Bohr, discussed the consequences and mysteriousness of quantum entanglement their entire lives. I hope that after explaining quantum entanglement, you can see the similarities with our definition of dualism 1. So, let's first state quantum entanglement. It states that given that the particle-antiparticle pair is produced out of a single source of well-defined energy, then those pair of particles are entangled with each other irrespective of the loss of space and time. Now, what do I mean by well-defined source of energy? It means that I have to have an energy source with a specific wavelength. For example, green light has its own unique energy, red light has its own unique energy, and so on. So the energy of the source is specified by its color, or in other words, by its wavelength. Now, this well-defined energy source under right conditions will spontaneously produce particle-antiparticle pair. This phenomenon is known as pair production. It has been observed that several properties associated with the particle and the antiparticle have a complementary relationship. This is inevitable considering how an antiparticle is innately complementary with respect to a particle, at least in some aspects. Now, let's look at a specific example of creation of an electron and a positron out of a gamma radiation of energy equal to or greater than 1.02 mega electron volts. Note that the energy of the gamma radiation is specific, well defined. Now, under right conditions, this gamma radiation will spontaneously produce a particle, aka the electron, and an antiparticle, aka the positron. Let's have a look at the complementary properties between the electron and the positron. The charge on the electron is negative, while the charge on the positron is positive. There exists a quantum mechanical property associated with the particle called as the spin, which also exhibits a complementary relationship. Honestly, it's difficult to explain the property of spin, but it suffices to say that spin is a property associated with the particle, just like the mass of the particle or the charge on the particle. The spin on the electron is half. Now, why is it half is something that we don't know. Electron and positron belong to a class of particles known as the fermions, which have half integral spins. Because the spin on the electron and the positron is half, therefore there exist two possible orientations that the particle can take when measurement is done. Let's call those two orientations as spin up and spin down. Note that these orientations are taken by the particles only when the measurement is done. Now, let's make this situation more dramatic. Let's say that the electron and the positron produced out of the gamma ray radiation have reached opposite edges of the visible universe. That is, the distance between the electron and the positron is several billion light years. Now, let's bring our measuring instruments and let's measure the spin on the electron. Let's assume that the spin on the electron is found to be up. Now, a crazy phenomenon occurs. The moment the spin on the electron was measured to be up, the spin on the positron will be spin down instantaneously. Let's take a moment to imbibe the craziness of this phenomenon. You are at one end of the universe, measuring the spin on the electron. You got the spin on the electron as spin up. Now you don't have to measure the spin on the positron. You know that it is spin down. You might ask, what's so crazy here? To understand this, we have to understand a physical law which has been proved beyond any doubt, and it states that the maximum speed with which one can transfer any information across the universe is at the speed of light. This means you cannot transfer any information faster than the speed of light. But in our example of quantum entanglement, the information regarding the electron's spin reaches positron instantaneously. This phenomenon in which the spin on the positron changes instantaneously is called as quantum entanglement. Now, reportedly, Albert Einstein was very disturbed with this phenomenon because it was his law, which is the special theory of relativity, which stated that the maximum speed with which information can be transferred across the universe is at the speed of light. In fact, he called this phenomenon of quantum entanglement as a spooky action at a distance. And if Einstein can be spooked by this phenomenon, one can imagine how crazy this phenomenon of quantum entanglement must really be. Now, what was the point in explaining all this? The point is to highlight the complementary relationship between the electron's spin and positron's spin. Let's assign spin up as A and spin down as B. Note that all the complementary relationship comes into picture only after measurement. We measured the spin on the electron as spin up, and only then the spin on the positron was found to be down. Without measurement, we wouldn't come across this complementary relationship. So, we can conclude that there are two worlds, two realms. First is the world of measurement, and the second is the world of non-measurement. Duality is a natural consequence of measurement, and the consequence of non-measurement is non-duality. That's all for this video on Dualism 1. I hope that you can appreciate how measurement and duality are connected, and how in a world of measurement, duality is a natural consequence. I hope you have understood the components of Dualism 1 which was explained in this video. In the next video, I will be dealing with Dualism 2, and let me give a little heads up. Most of the dualistic Indian philosophies fall under Dualism 2. Also, there exists a ton of analogies in physics that are in line with Dualism 2. Thank you.